Okay, we're back looking at Dr. Walden's paper on car prices. And so, again, we said there are two variables that are important. Now, they're all important, but the two most important to him, again, sometimes I call the hook variables. The hook variable is really why should you be interested in this paper to begin with, right? And this whole paper is about these geographic restrictions. And so the variable that the whole paper turns on is basically anything that has to do with geographic restrictions. And so since there are two of these, one that is just a variable that's going to change the y-intercept of the relationship between price and the other variables, and this one that is going to allow a different slope between population growth in states that have restrictions and those that don't. We're going to need to look at both of these variables at the same time in order to see, is there a relationship between geographic restrictions and price. Now, let's go ahead and look at the results here. Now, normally, and this is what we see here, normally before you just present the results, you want to back up and tell people, okay, before I tell you the results, I checked everything I need to check, and here's what happened, right? Because people want to know that there weren't any big problems before they start listening to your results. So you need to convince people, I checked what I needed to check and there were no problems. For example, in this first paragraph, Dr. Walden tells us that one problem you might have in a regression could be that some of your explanatory variables are extremely highly related. And we're going to look at this in the next series of lectures, lecture 5, where we look at some of the technical requirements for having a good regression. And one of those requirements is you don't want to have an extremely high correlation between your explanatory variables. And so he tells us that looking at the correlation of the independent variables, most of the variables have a correlation with each other of 0.30 or 0.40, but that there is one very high correlation between two variables. Distance, this is the distance the dealer is from where the car was made, and gas price, there's a high correlation. Now, my guess would be that that correlation is positive, yes, and it doesn't matter if it's high in positive or high in negative, but these cars are assembled in Ohio, I believe, and the further you get from Ohio, gas prices tend to go up quite a bit. And so he also goes through some other potential econometric issues with the data and the model. And so these are technical details that you need to address, but again, we haven't talked about those yet, so don't worry about them for right now. Still talking about some possible issues and trying to tell us, don't worry about it, it's not a problem, right? So you need to convince people that there aren't problems. Now, here is a table of descriptive statistics. Also required. You have to do this in a paper. Now, as I was mentioning, sometimes I like to put the units of the data in the table previously, table number 1, where the sources and the description of the variables were. But Dr. Walden puts them here in his descriptive statistics table, which is also fine. He has price. He tells us that that's in dollars, not thousands of dollars, just dollars. Same thing with income and gas price. And sales tax is in percent. These are in percents. Household size is in number of people, miles, persons. So he tells us the units of all these variables, except he doesn't tell us the units of these because these are dummy variables, except for this interaction term. This is a dummy variable times the population growth. So all of these variables, we know the units, we know the means, and the standard deviations. Sometimes I think it's also good to put in the minimum and the maximum values for these variables. Now you can get a feel for that from the standard deviation, but I like to see the minimum and the maximum to make me comfortable that maybe there aren't any problems with the data. Sometimes you'll look through a paper and you'll see that say the gas price, the average is $1.53, that makes sense. The standard deviation 16 cents, okay, that makes sense. But then you might see the minimum is 10 cents, and you'll wonder, where can you buy gas for 10 cents? It makes you feel like maybe there's some typos in this data. So I like to see the minimums and the maximums to just help me be comfortable with the data and make sure that everything's okay. So he also tells us the sample size is 539 prices of cars. So after looking at the table of descriptive statistics, also a must-have, he goes through and starts talking about the signs of the variables in the regression. So let's look at table 4. These are the results. It tells us the name of the variable, the coefficient, and the t-stat. Now we're not going to worry about the t-stats right now, except again to say that the t-stat, the bigger it is, the more confident we can be that the value of this variable really is positive or really is negative, and it's not just a random variation that's causing this, that it's evidence of a real, permanent relationship between the variables. So again, the dependent variable is price in dollars, and so we have the y-intercept. If all of these variables were 0, it's just a placeholder, but the car would cost minus $1,130. We don't take that seriously. Income is the income, this is average income of people in an area, goes up by $1,000, then the price of a Honda Accord goes down by $15. Now this might be contrary to what you would expect, and so if you get something where, well, why isn't it the fact that when people have higher incomes, shouldn't people be willing and able to spend more money for a product? Yes, that's typically what you would expect. However, what you would try to argue is, yes, this is negative, but perhaps it's because people with higher incomes are more shrewd at negotiation and haggling, and they have more information about prices. And so you might try to explain, yes, that's not what we expected, but perhaps here's what's going on. Gas price. As the gas price goes up by $1, car costs $921 less. That's a big decrease in the price of a car, but it's also a huge increase in the price of gas in this sample, since he told us the average was about $1.50 back then when this data was collected. Sales taxes, young percent of the population that's young, percent that's old. In this case, we would say for each 1 percentage point that as the percent of the population in an area goes up, who is older than 55, goes up by 1 percentage point, the price of the car goes up by $14.09. Not a big effect. Doesn't seem to be a big important effect here with the price of these cars. Now, since I'm about out of time, let's skip down to the r-squared, and then we'll look at a couple of the other variables in the next section. Look at the r-squared 0.80. You remember what that means? That 0.80 tells us that 80% of the variation in the prices of these cars can be explained with this model, looking at straight lines, only linear relationships, no curves. So 80% of the variation in the prices can be explained with this model, and that means there are 20% of the variation that we cannot explain with this model. So we'll come back and look at a few more of these coefficients and the rest of the paper, a few more of these sections and necessary details that have to be in there.